Good morning, my lovely 12s. Right, buddies, here we go, our second ever lesson of mechanics. It should be a really good one because we're going to do something that I really enjoyed today. And we're actually going to derive all of the Suvat equations together. So it might be a big-ish lesson, but I want you to make sure you're participating and following along. So it'll be a really good lesson. I'm very excited. So to start with, please put the title Acceleration for me, please. Now, you guys already know, my buddies, that acceleration just means that you're going to make something go faster. Now, you've got another one, which is called deceleration, which just makes stuff go slower. So you can decelerate if you're on the motorway. You could decelerate to get off the motorway, or you could accelerate to get on the motorway. But actually, deceleration and acceleration are both the same thing. They're both technically accelerations, but deceleration is just when the acceleration is opposite in direction to the speed. In other words, something slows down. In other words, decelerations are usually negative. So that's basically where we're at. So just to prove something to you, you guys already know before we do all of these amazing formulas that I'm about to show you, you already know how to do acceleration without me even needing to teach you. So let's see. This is my amazing statistics that I've actually looked up for my amazing car. Okay, my Peugeot 206 goes from 0 meters per second to 28 meters per second, which is actually 60 miles per hour, in 14 seconds. What is its acceleration? Well, push pause and see if you know what the answer is to that. Okay, and I bet you got it. I bet you did this. Acceleration, I bet you would have guessed that the variable for that's going to be a, which is great. So a equals, and the acceleration is this. It's going to be the change in speed. So it's going to be the 28, take away 0, because it gained 28 meters per second of speed, divided by how long it did that over. Because acceleration is how much speed you can gain in a certain amount of time. Which means we get this. Acceleration is just going to be 28 take 0, which is 28, divided by 14 is 2, and the units on it, again, just like last time, are meters per second squared, which you can think of as meters per second per second. So in other words, my buddies, my car, the actual statistics for my amazing, super quick, super fast car, is it gains 2 meters per second every single second. In other words, it's 2 times 3.6. It gains 7 kilometers per hour every second, or divide by 1.6. 4.5 miles per hour per second is what it gains. Now, I don't know if you know anything about like Peugeots and Corsas and the kind of smaller cars and the like, but that's not actually very quick. That's not a very quick and accelerating car. So here we go. I found this example too. It's a Lamborghini, and I looked this up. It's a real number. I forget which one I looked up, but it was whatever Lamborghini it was, can do it in 2.8 seconds. What is this one's acceleration? Well, check it out, buddies. If you did it with a Lamborghini, here's the deal. It ends up at 28, take away 0, because that's the speed it started with, and then divide it by 2.8. Well, 28 divided by 2.8 is going to be 10. So it actually does it in 10 meters per second squared, which means it's actually gaining. If you think about it, 10 meters per second is an awful lot. So 10 times 3.6, it gains 36 kilometers per hour every second, divided by 1.6, which is the same as 22.5 miles per hour it gains every single second. So that's a little bit more impressive than my car. But anyway, what I was going to show you about these, my buddies, is you actually already know a formula for acceleration. And here it is. Acceleration, buddies, is v take u over t. Now, this isn't the regular formula, okay? This is. So you can write them both down, but this one that's over to the right with the subject as v is actually critically important. It's one of the Suvat equations, which I'll tell you about in a minute. Here's what the variables mean, my buddies. A is acceleration. Okay. V is going to be final velocity. Okay. So this is the speed that you end up with. U is the initial velocity, and t is time. Do you remember last lesson when I said s equals ut? And we did the constant speed one, and I said velocity is u for whatever reason. Well, this is why. Since the velocity stays the same throughout, and s equals ut when you're doing constant speed, that's why they use u there, my buddies, because v is reserved for final speed. That's how come, the final velocity. So there you go, my buddies. This is the format that you want, though. V equals u plus at. There's going to be 5 of these. And you used to have to memorize them, but you don't anymore. So just make sure you've got that somewhere safe. Put a square around it. V equals u plus at. Now here we go. Today's lesson, and it might take a little while, but it's definitely worth doing because it reinforces everything that you need to know about graphs and everything like that. Today's lesson is to derive these equations, my buddies. There's lots of equations that we can use for constant acceleration. Now, here's what I've done. In order to get these equations, I've just drawn a standard old velocity time graph, which you should copy into your books. Now, this is the general form of a velocity time graph, okay? Because if you think about it, I'm not starting with velocity 0, because remember, velocity is on the vertical axis here. I'm not starting with velocity 0, I'm starting with an initial velocity. It speeds up, and it ends up at a final velocity. It does that over a certain amount of time, and because the graph is straight, it means that it does it at a constant rate. So this is constant or uniform acceleration. Happy days so far, my buddies? Cool. What can I label then, this bottom green dot that's just there? What's that the same as, my buddies? Well, yeah, it's the initial speed. What variable did we give that? Well, u. That, my buddies, is the initial speed. What's the second dot going to be? Up here. Well, v, the final speed, because it's speeding up. Now I think I've hidden things coolly underneath here, so let's see, which means, my buddies, that, oh, that distance up there is equal to u as well. I kind of regret trying to hide these. I wish I just had shown them. So that speed is u then, isn't it? That distance is u. This distance between 0 and u is going to be u. Cool beans? What about the distance? Oh, I didn't do one for v. What about, oh yeah, I did this over here. What do I do for this one, my buddies? Well, what's it going to be? Well, if you check it out, shaboosh! That height is then v, because that is the distance between 0 and v. That height is v. Now, we're kind of getting our thing all nicely labeled here, and we know that we're accelerating with respect to time. Or sorry, this question's all about time as well. So this point here, if this is the time axis, it all happens in a certain amount of time. I'm just going to call that variable t. So I've got it all in letters because we're completely general here. We're proving and deriving things. Which means how wide is this distance, which I've highlighted? Well, t. You're dead right. That distance has to be t as well. Cool? Which means all I have to do is pop, oops. Oh no, it's not working this time. It's not funny. How come that's not working? Shape outline. Oh dear. Ah, there we go. Okay. So that means I can break this thing down so it looks like a trapezium, but I can break it across as well that it looks like a rectangle with a triangle. Now, here's the thing. If I'm going to make you guys do a whole bunch of distances on this thing, well, here's what we're going to have to look at. I know how tall this is. I know how wide this is. So the area of this box is going to be UT, right? Definitely. Now, if I wanted to do the upper one, it's not quite clear, but I'm going to show you something, and I'm just going to see if you can spot it. This here, buddies, is actually AT, that height. Now, you can see it if you look at our little formula up here. Remember how we just discovered a minute ago that, like, when you rearrange your acceleration formula, that v equals u plus at? Well, this is v, that's u, so v is going to equal u plus at, and that's actually where that formula comes from. So that's at, that's the acceleration times time, because that actually does make a velocity, and so essentially the starting velocity plus the new velocity is equal to the total velocity. Or, just looking at the formula, which is what I like to do, you can see that the at is what's missing, so that's at. Cool. So I hope that you have your head around how this graph is working. Now, one other thing you got to remember, when you find the area under a velocity time graph, what is the area equal to? Well, if you said displacement, you're absolutely right. Cool. Here's what we're going to do. Number one, and it's down in the yellow at the bottom, so I've just got this, just the awkward amount of scroll down it looks like. Here's what I want you to do. I want you to tell me an area, I want you just to calculate the area of the trapezium that this makes, okay? Because that's actually going to unlock a formula for us, which we're going to use forevermore. Okie doke, so let's do it. Find the area of the trapezium. So first things first, let's look at the trapezium. You know the formula for trapezium, because you can sing it. Half the sum of the parallel sides times the distance between them. That is how you find the area of a trapezium. So it's half the sum of the parallel sides, which is going to be the left side and the right side. It's kind of like a trapezium on its side. This is the top and this is the bottom, as you like look at my mouse there. So bottom, top. So it's half of the sum of them, which means you add them together. U plus B times this is between them. T. Cool? In our picture? There's just one other thing. So that's what the area is. But what does that area actually represent under the graph? Well, if you said it's displacement, you're right. So you ready? S is the variable we had for displacement last time. Remember how we used S equals UT and S stood for displacement? That's what it is. So you ready? S equals a half U plus V T. Boom. That, my buddies, is one of your Suvat equations. So if this up here was equation 1, this is going, oh, actually I needed to use this as equation 1. This is equation 1. That's what you've got, my buddies. I'm going to take that away because I think I use the numbers later on. Okay, look, you've just come up with an equation. So that means if ever you know an initial speed, a final speed, and a time, you can calculate how far something went. It's quite powerful, this. You've just unlocked a brand new way of calculating with acceleration that doesn't even use acceleration. Cool. Here's what I'm going to get you to do. I want you now, all by yourselves, without me, to do question 2. I want you to come up with the area of the triangle and the rectangle together, and then make S as the subject. So I treated it like one parallelogram. You need to treat, or sorry, one trapezium. You need to treat it like this area plus that area, and then come up with a formula for me. Go. Okay. So, happy days. So there's our first equation for number 2. Let's see if you did it. Well, first things first is I'm going to be finding an area, so straight away I'm going to call that S, because the area underneath the curve is going to be S. Definitely, because it's displacement. It's under a velocity time graph. Well, what's the area of this bottom rectangle? Well, it's length times width, UT. Cool. What have we got here in this top one? Well, it's a triangle, so it is going to be a half. Now the height is AT and the base is T, so this is like a half AT squared is what you've got for that triangle. So our formula is going to be S equals UT plus 1/2 AT squared. Boom! You've just derived a second formula. So you could feel like scientists or something here. You're deriving formulas left, right, and center. S equals UT plus 1/2 AT squared. So if ever there was a question that needed to figure out how far something went, but you didn't know how fast it started with, or sorry, you didn't know how fast it ended up going, you can calculate with this one. Sweet! I wonder if there's other formulas we can get from this. Oh yeah, there is as well. We can also get at one by finding the area of the big rectangle and taking from it the triangle, which means you could find the area of this entire thing, so the entire thing, like one big rectangle, and then you're going to subtract off this part. Cool? So you guys ready? Go! Okay, and hopefully you're back. Hopefully you got it. Well, you'll have found this, my buddies. The area of this triangle is actually the same as the other one. It's a half AT squared, and the reason why this upper triangle is also a half AT squared is because if you look at it, the height of it is still AT, so even though it's on the right-hand side, this is AT also. So it's AT, so that's the height, and the base is still T, so it's a half AT squared, no problem. But the only difference this time is we can go the entire rectangle, well, its area is actually going to be VT. Get me? All the way around the whole outside. And what are you going to take from it? Take that green triangle I just drew. Take away half AT t squared. Boom! We now have a formula that we can use when we don't know an initial velocity, because u's not in that formula. So happy days, not playing games. And finally, the last one that makes you absolutely legendary at this is going to be this. All you're going to do is you're going to start off by taking our initial formula, which is the one for acceleration, v equals u plus at, and you're going to put it into 1. Okay? So you're going to put the v equals u plus at into equation 1. Cool? So if you think you're ready for it, so you can see this, you can see that v equals u plus at to start with. I want to see if you can do it, okay? So step 1, arrange this for t. Step 2, pop it into 1. Step 3, rearrange it for v squared. Go. Okay, and here we go. Let's see if you did it. So you'll have had this then. You'll have had at equals v take u, which means that we're substituting it for t, which means t equals v take u all over a. Now, what are we going to do with that? Well, it told us to pop it into number 1. So s equals a half, open bracket, u plus v, but where I had t, I'm now going to put in v take u all over a. I don't know why I drew that bracket so enormous. Yeah, v take u all over a. Cool beans, my buddies? Which means s equals, and here we go, it's going to be like, what are we going to do? How do we want to do it? We're going to do this. We're going to go 1 over 2a, so I'm smushing the fraction parts together, and that just means that on the top, what I'm going to have is I'm going to have a u plus v times by v take u. Cool? So the bottoms are that, the top is that. Cool. S equals, and let's do it. Foiling it out, we're going to get this. We're going to get uv minus u squared plus v squared minus uv. And it's going to be all over 2a because I'm just going to smack that underneath. Cool? Which means that s equals, the uv's are opposite in sign, so they're going to cancel, and I'm going to go v squared take u squared. Cool? So I just put the positive one first, all over 2a. Cool? And that's it. We've substituted in. We're flying here. We're acing this. The final thing we need to do is rearrange it to make v squared the subject. So starting off by timesing both sides by 2a, 2as equals v squared take u squared. And then you ready? V squared equals u squared plus 2as. That is your final Suvat equation. So that is 4. Cool? This final one, well, that's your final one. And again, just to remind you, the one that we had earlier was v equals u plus at, which you just got that with logic. You already knew what acceleration was. And there you go, my buddies. You've got your 5 Suvat equations. Those, you lucky ducks, I'm gutted about this actually, but these are in your formula book now. They didn't used to be, so you don't have to memorize them, which makes me upset. I think you should have had to memorize them. But here you go. There they are, buddies. Make a nice note of this, okay? The title is The Suvat Equations, and write them all down. There they all are in a nice list for you. V equals u plus at, s equals ut plus half at squared, v squared equals u squared plus 2as, s equals a half u plus vt, and vt take 1/2 at squared is also s. Cool beans? Jot them all down. You don't have to memorize them, unfortunately, but there they are. I'm going to tell you why they're cool. They're going to be able to solve so many questions with these. And there's something just to note about them. They're called the Suvat equations, first of all. Why do you think they're called the Suvat equations? That's right, because it represents every variable in these equations. Displacement, initial velocity, final velocity, acceleration, and time. That's why they call them Suvat equations, okay? It's not special. It's not even a word, Suvat. It's just an acronym to help you remember all of the equations. It's like SOHCAHTOA. It's the same as SOHCAHTOA, that it's not actually a word. It's just to help you remember the trig ratios. Suvat is to help you remember the constant acceleration formulas. So you ready? Here's why they're useful. See, this one says v equals u plus at. Which of the Suvat letters does it not have in? Well, s. Put a little bracket and an s next to it. If you ever have to solve something and you don't know s and you don't want s, you use this one. What letter is this one missing? Well, v. If ever you need to solve something, I regret not putting them in Suvat order now, but yeah, v is missing from this one. What's missing from this one? Well, time is. What's missing from this one? Well, A is. And what's missing from this one? U is. You ready, buddies? S-U-V-A-T. You choose which one you want based on what is missing. So I hope you feel okay at this, or I hope you'll feel all right at this. Students really like this topic usually. It's not too bad at all. And let's do it. Here we go. Let's check it. First ever Suvat question, okay? A car moves from traffic lights along a straight road with constant acceleration. It needs this word, constant acceleration. Constant acceleration means that we're allowed to use the Suvat equations. If the acceleration wasn't constant, then in the velocity time graph, that line wouldn't be straight. If that line isn't straight, our equations aren't right, because our equations were made up based on that line being straight. Cool. The car starts from rest, okay, so that's a point, from rest. And in 30 seconds later, the car passes a speed trap where it's going 45 kilometers per hour. Now, question A says, find the acceleration of the car. Now, here is how you're going to do every single question. This one here doesn't actually need a direction, but I'm going to add one because it's going to help us later when we got to do hard questions together. So here we go, buddies. I'm going to presume that our car is like there. You don't have to draw a picture, not for this one. This is an easy one. But I'm going to presume our car is going right like that. Well, then here we go. Define a direction to be positive and just write it like that. Right pause. That's all. That means whatever direction is right, I'm saying is positive. Now, first step in all of these is this. You write Suvat. Downward though, okay? S-U-V-A-T. Suvat. Equal sign next to each. And you just go through and you say to yourself, what do I know and what don't I know? So S to begin with. It starts from rest, blah, 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 blah. Do we know what S is? No, it's not given in the question. Cool. U, do we know what the initial speed is? Well, yeah, it says it starts from rest. The initial speed is 0 meters per second. V, the final speed, the speed it ends up going. Do we know that one? Yeah, we do actually. It's 45 kilometers per hour. But instantly there's a problem, buddies, because that's not a standard unit. So when you do this in physics and when you do it in maths, you're going to want to use standard units. Kilometers per hour is not a standard unit. Meters per second is. So what's the thing that we've got to times or divide by? Can you remember from last week? That's right, it's 3.6, okay? So you just divide this by 3.6 and you go 45. 45 divided by 3.6 equals 12.5. So 12.5 meters per second. Acceleration, do we know the acceleration of the car? No, put a question mark. But actually, that's what we want if you read the question. It wants us to work out the acceleration. So if it wants us to work out the acceleration, it is a question mark, but it's the one we want. So I draw a square around it to show that. And T, do we know how long it takes? Well, yeah, 30 seconds in the question. Because I've included units all the way through this, meters per second, and seconds, that means I don't have to write units anymore in my question. And that's what I suggest for you guys. Okay, so here you go. We need A, and we don't know what S is, and we do know what the other things are. So we need an equation that doesn't have S in from Suvat. Which one is it? That's right, it's the top one, buddies. It's the top one. So step one in all of these questions is you write V equals U plus AT initially, okay? You write down the one that you want. I'm going to let you skip this step for the substitution step, literally the lesson after this one. But for now, it'll do you good writing down the formulas. It'll stick them in your head. Cool. Now, what you're going to do is called inline substitution. You're going to put them all in place. We're not going to change the subject first. We're just going to put everything in place. So V is 12.5. Equals U, which is 0, plus A, which we don't know, open bracket, 30. Cool? So 30A equals 12.5. So A equals 12.5 divided by 30. 5 divided by 30 is 5/12, but we're physicists now, so this is not 0.417. Not 0.417 meters per second squared. I knew the unit would be meters per second squared because I was really careful to get everything in the standard units. Cool. Now, next thing then is we're ready to try the next part. It says find the distance between the traffic lights and the speed trap. Okay, now here, remember how I kept saying that people always use these words distance and displacement interchangeably? There's only sometimes they try to fool you with it. We're going to talk about that next lesson. But the distance is the displacement. It is just going to be the distance between the two lights. So you ready? What do we do? What do we do? What do we do? Well, for B, it's actually the same scenario as before. So what we're going to get is we now know that the acceleration is not 0.417. I don't think I need to rewrite my givens because they're almost the same, okay? It's not fundamentally changed this question. So I just need to get S. And actually I know 1, 2, 3, 4 things now. So I can use any equation I want for S. Which one do you want? Okay, well, I'm going to use this one, the half brackets u plus vt, and the only reason I'm going to use that one is because, you know, I just calculated the acceleration. What if I made a mistake? So I want to use this one because it hasn't got acceleration in, but you can use any. We'll all get the same answer. So I'm going to use s equals half u plus vt. So s equals 1/2 u plus vt. Let me do it in blue. S equals 1/2 u plus vt. From next lesson, I won't make you copy the formulas, but it's good for you to try to learn them. Okay, u is 0, v is 12.5, and that happened in 30 seconds. Bish bash bosh it into your calculator, so it's just going to be 15 times 12.5 is going to be 187.5. 187.5. The units are meters, because I kept everything in standard form. So I hope that you're getting Suvat then, my buddies. Not too bad, eh? Cool. One final one. Here we go. Okay, a little bit harder, I think. A particle is moving in a straight line from A to B with acceleration 5 meters per second squared. The velocity of the particle at A is 3 in the direction of AB. The velocity of the particle at B is 18 in that same direction. Find the distance from A to B. Okay, only because they're being fiddly. Yeah, this is maths getting involved in physics here. So this is written as a maths question, even though this is a physics question. It is written as a maths question, so you can see there's vectors in it. It probably lends itself well to a picture because it's on about A's and B's and stuff. So I'm just going to do a quick jot just to help our understanding. It's going from A to B, right? Beautiful. Now it says straight away, my buddies, that it's got a constant acceleration of 5 meters per second squared. So the acceleration is 5 meters per second squared, standard unit, which is great. It says that the initial speed at A is 3 meters per second. See, I'm just going through and finding bits. Okay, I'm rereading the question in order, and I'm just trying to find bits, okay? 3 meters per second. In the direction of AB, so it's 3 meters per second. It is going this way, okay? The acceleration, or sorry, the velocity is going that way. Cool. And then by the time it gets to B, it's still moving that way because it says in the same direction. But this time, V, the final speed, is 18 meters per second. What does it want? It wants the distance, which is S. Okay? Right, so there you go. Now we all have a clear understanding of what's going on, and let's do it. Part 1. I know we don't need it yet, but I want you to do it anyway. Define a direction to be positive. This is going to help you massively in the future. If you define it wrong, you'll still get the same right answer, so it doesn't even make a difference if you say it wrong. It's sensible to say right is positive because everything's moving to the right as I've drawn it in my picture. Step 2, for every single question. Suvat. Suvat. There it is. Step 3, start whacking numbers in. So S, do we know it? No. Is it the thing that we want? Yes. So put a square around it. U, the initial speed, do we know it? Yep, 3 meters per second. V, the final speed, do we know it? Yep, 18 meters per second. A, the acceleration, do we know it? Yep, 5 meters per second squared. All of these are positive because they're all toward the right. Time, do we know it? Nope. Do we care? Nope. Don't draw a square around it. Happy days. Now we just need to find the Suvat equation, the one that hasn't got t in. Which Suvat equation doesn't have t in, buddies? That's it, it's this bottom one, because the helpful bracket thing that we drew next to it. It's the bottom one. It's v squared equals u squared plus 2as. This is the one that doesn't have t, because t is the thing that we didn't know and we didn't care about. So, what equation are we using? Well, v squared equals u squared plus 2as. writing it down because I'm going to get it into your brains soon enough. You won't have to copy it out. You can substitute straight away. Okay, inline substitution. Don't rearrange it. Just do it. 18 squared equals u, which is 3 squared, plus 2, open bracket, 5. Don't put 10 straight away. Show that you made the substitution. 2, open bracket, 5, and s, the thing that we want. I'm sorry that my s's look like 5s. I'm conscious of that. Okay, let's start working it out. 18 squared, and you don't actually get marks for the workings out, so you can skip algebra steps a little bit here, but make sure you're good at it, by God, if you're going to. 324 is equal to 9 plus 10s. Okay, now probably all of us are good to skip steps from here. So 324 take 9 equals 315 divided by 10 equals 31.5. So straight to the final answer of 31.5, and the units are meters because I made sure everything was in standard units. Cool. So I hope that you feel good. I'm not at these questions, and I hope that I've not muddled you or confused you on it. This is brilliant. If you can do the same exact steps every single time, you couldn't make me happier. And literally, even if you get the question wrong, if it's worth 6 marks, I'll still be able to give you 4. So it's so awesome to lay it out this way. You've got to do it the way I'm doing it. And that's it. So for the rest of this lesson, I'm going to get you just to try these. I need to explain them a bit. Page 140, question 1 to 6, and do a mix. And page 145, question 1 to 6, and do a mix, okay? Do as many as you can. That's 12 questions. I bet you could probably do them all because this video has taken half an hour, it looks like. I bet you could do almost all of those questions. Now, if you can't quite do all of these questions, even including your extra 20-minute homework time, if you can't do them all, that's okay. Just do your best to do a mix. Say do 4 from each section if you can. And here's the extra thing, which I never ever say to you, but I am going to say to you today. Don't really try any hard ones, okay? Don't go past 6 yet. Okay, I'm only trying to build you into a pattern yet. Or I'm trying to build you into a pattern. That's what my goal is for today. I want these to feel routine and easy, and I want you to start memorizing the Suvat equations. And you'll do that by doing a bit of repetition and by reading questions slowly. Okay, so don't do question like 8, 9, 10, 11, 12, because next lesson I'm going to teach you how to do these harder nightmare ones, but you'll be so good and ready for me because you'll have done these already. So you're going to be at a huge advantage because you practice so many easier ones. It's going to help you out for the harder ones. So that's what my goal is. So 1 to 6 on each of these. Do a mix. When you're all finished, upload it on Show My Homework or Satchel One or whatever the devil it's called these days. And that's it. So that's it from me, buddies. Bye, buddies!